Welcome to all. My name is GV Prasanandinailu. So in this video, I am going to be explain about introduction of sequential circuits. Okay, let's start. So these are extensions of combinational circuits. Therefore, first I will go for a small recap of about combinational circuits. So let's see. So earlier we learned about combinational circuits and examples. In those, the outputs depends on the present combination of the inputs. In combinational circuits, the outputs depends on present combination of inputs. So now the representation of combinational circuits is shown below. So now see, here it is the combinational circuits. It consists of n input variables and m output variables. Okay, the values of output variables depends on present input variables only. So that is the main function of that combinational circuits. Okay, so next, various examples of combinational circuits. Earlier we already discussed, especially about half adders, full adders, half subtractors, full subtractors, magnitude comparators, decoders, encoders, multiplexers, demultiplexers. So the detailed concepts you can watch about my earlier videos. Anyway, so the summary part of those combinational circuits as characteristics, here it is mentioned. It consists of n number of inputs and m number of outputs are possible in combinational logic circuits. Okay, the main point is always the outputs depends only on present inputs. Outputs depends on only the present inputs. So that means these circuits do not have any backup or memory. So these 2 points are very important for our today's concept, that is sequential circuits. These circuits do not have any backup or memory. Next, the present state of the circuit is not affected by the previous state of the input. So if there is no memory, the present state is not affected by the previous state of the input. So these are the main characteristics of that combinational circuits. So just remember of all these points, then we will go for that introduction of that sequential circuits. So that sequential circuits introduction. So it is a special type of our digital circuits that has a series of inputs and outputs. That has a series of inputs and outputs, like as our combinational circuits. There is no difference particularly about this point. Next, now see the main point at here, it is the outputs depends on both the combination of present inputs, and previous outputs. So it is the main and very crucial thing in case of that sequential circuits. If it is a combinational, it depends on present inputs but not depending on previous outputs. But here these are depends on previous outputs. Okay, so then the concept is where these previous outputs are stored. So the previous outputs are stored in memory elements. So therefore the sequential circuits consists of memory elements. So now see the previous outputs. So these are our previous outputs. These previous outputs are stored in memory elements. Therefore again it is playing a crucial role in our sequential circuits. So now onwards, our sequential circuits consists memory elements. So the C. So these circuits contains the combinational circuit and its memory storage elements. It is the conclusion at here. Consists combinational circuits and its memory storage elements. So now I will be represent that sequential circuit So now see, as like our earlier, so a combinational circuit consists some series of inputs and outputs. For storing previous outputs, as like I discussed, so there is a need of that memory element. Therefore, so that previous outputs are stored in this memory element. Again, these are forwarded to our combinational circuits. Therefore, here this part we can be treating as feedback path. Feedback path. This path was absent in case of combinational circuits. So, but it is present in case of sequential circuits. So that is the main difference. Okay. So now onwards, in our all sequential circuits, this feedback path is exist. So some noting point at here. A sequential circuit doesn't need to always contain a combinational circuit. Doesn't need always contain a combinational circuit. So the sequential circuit can contain only the memory elements. Sometimes there is no need of combinational circuit, but it should be consists memory elements. So those are some special cases. So anyway, so once by representing sequential circuit, then we will focus on what is the differences between combinational and sequential circuits. So here those differences mainly according to that feedback path. So which elements are existed in feedback path as discussion is, so that memory elements are existed in that feedback path. Feedback path is not presented in combinational but presented in sequential circuits. So anyway, let's see the first one, combinational circuits, then opposite one, sequential circuits. So here the first point is the outputs of the combinational circuits depends only on the present inputs, only on present inputs. At here in opposite side, the outputs of sequential circuits depends on both present inputs and previous state. So previous state. So here the previous states are stored in that memory elements. So next, so it is regarding to feedback path. The feedback path is not presented in combinational circuits. The feedback path is presented in sequential circuits. So next, third point. In combinational circuits, memory elements are not required. In sequential circuits, memory elements plays an important role. So therefore, these should be required. Next, anyway, so if memory elements are not required, there is no need of clock signals. So that point here it is mentioned. The clock signal is not required for combinational circuits. Once memory elements are presented, the functioning of memory elements depends on clock signals. Therefore, the clock signal is required for sequential circuits. Next one, so it is about the complexity of design. So once there is no memory element, these are simple to design. The complex circuit is simple to design. It is not simple to design as like combinational circuits. Therefore, it is not simple to design a sequential circuit. Okay, so these are the some main differences between combinational versus sequential circuits. So then we will go for that types of sequential circuits according to the clock pulse. The types of sequential circuits based on clock pulses. So what is that clock pulse? We will go for about a discussion of that thing also. So before that, first of all, we will go for that types of sequential circuits. So that first one, asynchronous sequential circuits. Asynchronous sequential circuits. So what is the meaning of that asynchronous sequential circuit and those things we will cover. Next, synchronous sequential circuits. First one asynchronous sequential circuit and second one synchronous sequential circuit. This classification is based on clock pulses. So anyway, so first we will discuss about asynchronous sequential circuits. Okay. Here the clock signals are not used by the asynchronous sequential circuits. Next, the changes in the input can change the state of the circuit. So the internal state is changed when the input variables are changes. Okay. So as our discussion starting from that sequential circuits, the sequential circuits consists memory elements. So in general, which are the memory elements means, so latches or flip-flops. So about latches or flip-flops, I will discuss more thing about these things in my coming videos. Okay, so but remember here latches or flip-flops are the memory elements. Next, the unclocked flip-flops or time delayed flip-flops are the memory elements. So about clocked signals and their unclocked and their time delayed, I will discuss about more things in coming videos. So, next, the second one, synchronous sequential circuits. In synchronous sequential circuits, the clock signals are used. The output is stored in either flip-flops or latches. In general, these two are the elements of memory devices. So the output is stored in either flip-flops or latches. Next, the synchronization of the outputs is done clock signals. So what is synchronization? Those things also I will be covered in coming videos. Here I am showing to you the nature of clock signal. So now see, in general, the analog clock signal like this way. So now here it is indicating with 0 volts, here it is indicating with 5 volts. In digital form, we can represent this one as some logic 0. Automatically, it is representing with logic 1. Okay. In another way, we may represent this one as off state, then automatically this one is on state. Anyway, now see a clock signal starting from at here, it is rising like this way, then again it is falling, now again it is constant up to here, again it is rising. So in general, a cycle starts from here and ends at here. Again a new cycle starts at here, ends at here. A new cycle again, one more new cycle starts at here, ends at here. Okay, from starting point to ending point, the time taken for this waveform is known as time period. So that is represented at here, time period. So that means starting period to ending period, time taken for that cycle. Anyway, so once by representing like this, then we can treat it this one as on state. Similarly, this one is off state. Okay, so therefore the time taken for that on state is T on. Similarly, time taken for that off state is T off. Once by representing, then total time for the cycle is Tt equal to T on plus T off. T on plus T off. So simply it is the nature of a general clock cycle. Okay, 0 volts is representing with 0 and 5 volts is representing with 1. In another way, off state, on state, and its total time period equal to on time period plus off time period. So next we will go for that triggering of those clock signals, the types of triggering of clock signals. That first one, level triggering, and second one, edge triggering. So what is that level triggering and edge triggering? I will cover. So that first one, level triggering. So again there are two types. One is positive level triggering and second one, negative level triggering. So what is positive level triggering and what is negative level triggering? I will show to you with a diagrammatic representation. So now see, so in our clock signal, we already represented this one is on state. So anyway, now here a small duration of this one is constant. So we already treated this one is 5 volts, this one is some 0 volts. So therefore the triggering at this point is happens, that one is known as positive level triggering. Positive level triggering. Now see the opposite one, negative level triggering. So the triggering is happened at these durations. The triggering happens at these durations. I will show to you. So now see, the triggering happens at lower levels. At lower levels. If triggering happens at higher levels, that is positive level triggering. If triggering happens at lower levels, that is negative level triggering. It is about simply the level of triggering. Simply it is very simple point. It is positive level. Now here it is negative level. Okay. So then we will go for that second one, that edge triggering. Edge triggering. Again here also two types. One is positive edge triggering and second one negative edge triggering. First I will show to you that positive edge triggering. So now see, so the cycle consists as discussion, there is rising. So these are the rising points. All these are the rising points. Therefore, if triggering happens at these points, that is known as positive edge triggering. Positive edge triggering. The exact opposite one, if triggering happens at these durations, that is known as negative edge triggering. So now see that second one, the negative edge triggering. Triggering happens at falling edges. At falling edges. So simply that is known as negative edge triggering. If triggering happens in upward direction, that is positive edge. If triggering happens at negative edge, that falling, that is known as negative edge trigger. Okay. So with this, I completed about the definition of sequential circuit and how it is represented. Okay. So next, the differences between combinational circuits and sequential circuits. And third one, types of sequential circuits based on clock pulses. Next, fourth one, what is the nature of clock pulses and how that sequential circuits are triggered with clock pulses. So those four topics I covered in this video. Next, in coming videos I will concentrate about more on the types of flip-flops and latches. Okay, so for all of you, thank you for watching. Thank you once again.